given a position graph and asked to write an equation from that position graph. Questions that represent this idea are: write an equation that states how position varies as a function of time, or write a mathematical model that describes how the position changes with time. Essentially, you have a position graph that's linear, and we want to write an equation that tells the reader how the position changes with time and can actually be used to predict the position at any time. We'll start with the equation of a line y equals mx plus b, and we will simply substitute in for each of those different values. Let's start at the beginning with our variables. So our variables are going to be what's represented on our axes. So we've got our x and our y axes. So we're going to start with our y, and on our y-axis is position. Now, position is represented by the letter x, which can cause some confusion, understandably so. What you need to remember is that the letter x stands for position in the x direction. And so our buggy moved in the x direction, right? And so we're going to use the letter x to represent position in that x direction, all right? And then, excuse me, the next thing that we're going to do is we're going to identify what's on our x-axis, okay? And on our x-axis, which is this guy right here, is going to be our time. So we're going to use t. So now we're going to have an equation, and notice I'm leaving a space, and I'm leaving a space for our slope, which is our m, okay? So I put in my t, which is located on my x-axis. So now I have my variables in my equation, position and time, or x and t. Now I'm going to put numbers in my equation, and we're going to put in the slope and the y-intercept. Let's start with the slope. In this case, I'm going to use 2 points to calculate our slope. We see that the change in position, or the rise, is 2 meters. It goes from 1 meter here up to 3 meters. And then it goes, the run, we should say in our math speak, or our change in time, will be 3 seconds. So our slope, sorry, I'm having some tech difficulties. Our slope is 2 meters in 3 seconds, right? Because it went from 1 to 3. So that's 2 meters right here in 3 seconds. So our slope, I'm going to go ahead and put it in a decimal, is 0.67 meters per second. And I'm going to go ahead and put that in my equation, and I'm going to write it using parentheses. And I am going to include my unit. And I just use parentheses, not necessarily because it's that important, but I want to show that that's one thing, right? That's the slope or the speed of the object, 0.67 meters per second. And then our last task is to put in our y-intercept. Our y-intercept is where the initial position, or the position at time, is equal to 0, which is, again, at this point that's circled right here. And in this case, it is 1.0 meters. This is the complete position equation that represents how position changes with time. Position is equal to 0.67 meters per second times time plus 1.0 meters. You could substitute in any value for time, and then this equation will give you what the position is at that time.